Hello CS112. Today I'll be going over a quick solution to Lab 11 which has to do with files. So the gist of this assignment is that Luffy still has no idea where the One Piece treasure is at, however he found a note which might contain information about its location. However, this note is encrypted, so it is up to you to decrypt the file in order to reveal its hidden message. So that encrypted.txt was a file given to you on Blackboard, so it is important that you were to download it and place it in the same directory as your code files. You can see here, if I was to display the contents of my current directory, it has my code as well as the encryption.txt. So this is what the encryption.txt looks like. It is a file with a single line with a whole bunch of numbers in it. So what we're supposed to do here is we're supposed to read this this line essentially, read this file 3 characters at a time, and each of these 3 characters represents an ASCII value that we can convert to a human readable character. So that is what we're supposed to do, and once we convert it, we need to write it to a decrypted.txt. So I'm actually going to break this assignment up into 2 different parts, one where I actually decrypt the encrypted file correctly, and then after I make sure it's decrypted correctly, then I will worry about writing it to a new file. So that just means I'm going to display the decryption here first in my terminal before actually writing it to a decrypted.txt file. And actually, since I know you guys know how to work with strings really well, the first thing I'm going to do is I'm going to convert encrypted.txt to a string. So first I need to open the encrypted file to read. And I'm just going to name it efile equals open file name in the reading mode. And the very next thing I'm going to do, as soon as I open something, I'm going to close it. So efile.close. Now I do want to place all my code working with efile above closing it, or else I wouldn't be able to actually work with efile itself. So I'm going to move that down to the bottom of my function here. Now, as I convert it to a string, there are 2 quick steps I'm going to need to do. One, I'm going to create a new thing called efile.list, and I'm going to set that equal to efile.readlines. And what does that do? Let's find out. So I'm going to print efile list. I'm going to save this, and I'm going to run it. As you can see, what readlines does is it takes a file and it puts it essentially makes it into a list where each line in that file is an element. Well, since encrypted.txt only has 1 line, there's only 1 giant element here. Just to show you guys, if I was to break this up into multiple lines and run it again, it would have 2 elements separated by a new line. So I'm going to really quickly revert my encrypted.txt to be how it's supposed to be. And let's continue on. Well, since I know that the encrypted file will always be just a single line, I can directly say my efile string is going to be equal to efile list at the 0th index. So now I'm just going to have a one nice clean string that I can iterate through and work with. So now that I'm going to start iterating through and working with it, I'm going to be using range's full functionality as well as a little bit of slicing inside my loop. So range's full functionality, you have the start parameter, you have the end parameter, and you have the step parameter. So I'm going to be abusing the step parameter to sort of just do this function for me. So I'm going to say for I in range 0, because I want to start at the beginning, I want to end at the length of my string so I don't go past that. And lastly, I'm going to step by 3 because we're told that each of the 3 characters represents an ASCII value that can be converted to a character that we can read. So inside here, I said I'm going to be using some slicing. Well, I'm going to just create a variable called char, which can act as a temporary variable to represent the ASCII value. And I'm going to set that equal to efile string. And I'm going to slice it at the ith index, so wherever we're starting, as well as I plus 3. So that's going to take the ith through I plus 3 and make that into one small little string that I can convert into an integer and then into an actual character. It's important that you pair this I plus 3 with a 3-step here. For instance, if you were missing this 3-step here, you would eventually get to the point where you're trying to access a character that doesn't exist because you're going out of bounds. So now that we have that there, I'm going to convert char to what we need, which is an actual character. And sorry, I can't type while talking today for some reason. The way we'll do that is by using the chr method, which is described to us here on the assignment PDF, which transforms an ASCII value to a character. Each 3 of these represents an ASCII value. I do have to convert it to an integer because right now it's a string, and chr requires a integer. So that's why I'm doing that. And lastly, let's just print out what's char equals so we can see if what we've done so far. And I do want everything to be on the same line, so I'm just going to print it out like this. I'm going to save that, and I'm going to run it. And as you can see, I have printed out the actual thing here, which is One Piece is hidden on the deepest island of the Grand Line, the last island's later named Laugh-Tale by Roger himself. So now that we've made sure that we know how to actually decrypt the file, all that we need to do is change this one line of code here and actually open a file to write. So the first thing I'm going to do is open a file to write. So open decrypted file to write. So I'm going to say dfile equals open, and then I'm going to say decrypted.txt, and then I'm going to open it in the W mode so I can write to it. Now, how does opening a file in the W mode work? Well, as you can see here, I'm just going to clear my terminal real quick and ls. Well, encrypted is in the same file as cat, so that makes it easy to open and read it. Well, if you were trying to read a file that doesn't exist, then you would get an error that the file doesn't exist. So when you're opening something to read, the file must exist. However, if you're opening something to write, this file does not need to exist. In this case, decrypted.txt does not exist. So if you try to open something to write to it and it doesn't exist, it'll automatically create this file for you and start writing to it wherever you want. However, if decrypted.txt does exist within here, it'll start appending whatever you write to this file here. So that's a slight difference between the two. It's kind of common sense, to be honest, because you can't read something that doesn't exist, but writing, you can write something from scratch or add to the file there. So that's just something to keep in mind with that. And I'm just going to change this line here to be dfile.writeChar rather than to print it out. And the most important thing is to close your file. So now when I run this, as you can see here, I just want to make sure that the only 2 things right now are cat and encrypted. However, if I run cat, nothing happens here. Nothing else is displayed here. However, if I type ls now, you can see decrypted was added here through opening a file that doesn't exist, so it will create it for you. And if I open up decrypted, we now see the answer displayed here. So yeah, wait, I actually think we're supposed to, I think I remember somebody saying to print your name at the end of this, maybe? Or was that lab 12? I'm not sure. I'm just going to go ahead and say dfile.write my name. Let's go ahead and say I'm Luffy. Gonna run that one more time. Python cat.py. Let's go to our decrypted, and funnily enough, it is on the same line, so we are going to need to move it down one, and I can simply add a new line character there. And if I run it again, and I go all the way back here to my decrypted, you now see Luffy here. So if you have any questions, feel free to leave a comment below or ask on Piazza.